So hello students, so question is the difference in oxidation number of the two types of sulfur atoms in Na2S4O6 is. So Na2S4O6, in Na2S4O6 structure, if we see the structure is such that S and here its oxygen is 6, so it is double bond oxygen. And it is Na plus. So here it is oxidation state of sulfur, here it is plus 5 and here it is also plus 5, and the oxidation state of both this sulfur, it is a 0 and 0. And the question is the difference in the oxidation number of the two types of sulfur atoms in Na2S4O6. So two different types of sulfur is one this sulfur and another this sulfur. So difference here is 5. So here the difference is 5. So correct answer is option first. Hello students, question is in the reaction NO2 minus plus H2O gives NO3 minus plus 2H plus N electron, and what it is asking the value of N. So it is asking the value of N. So in this reaction the NO2 minus plus H2O, it gives NO3 minus plus 2H plus N electron. So if we see here on the reactant side it is a -1 and on the product side it is also a -1, but if we see here it is 2H plus. So in order to balance this, it will be a 2 electron minus. It will be because we have to add here the 2 electrons. So it is going to cancel out each other. So here it is the value of N will come out to be the 2. So the value of N is 2. Hello students, so the question here is given below are the two statements. The moles of KMnO4, statement 1 is moles of KMnO4 required for oxidation of iron plus 2 in the acidic and the basic medium will be different, and statement 2 is given the final oxidation state to which Mn plus 7 will be reduced will be different in case of acidic and the basic medium. So in the light of the above statement, choose the correct answer from the following option given below. So the first statement, that is the KMnO4 required for oxidation of iron plus 2 in acidic and the basic medium will be different because it depends on the medium. That thing will be the KMnO4 in different medium, in acidic and the basic medium, it will be a different. And for the statement 2, the final oxidation state to which Mn plus 7 will be reduced will be different in case of acidic and the basic medium. Because if we see the MnO4 minus in the acidic medium, it will convert in Mn plus 2. It will convert in Mn plus 2. Similarly, for if we talk about a neutral medium, so in the neutral medium it will convert into the Mn plus 4, and the same the way is if we see in the basic medium, it will convert into the plus of 6. So it depends on the medium, it will be vary. So according to that, statement 1 and statement 2 both are correct. So our correct option is option number 2. Hello students, so question is given below are the two statements. The statement 1, if the normality of a KMnO4 solution is 0.5 normal, then the normality of a same solution may be 0.3 normal in other condition. Statement 2 is given as equivalent weight of any substance may be different in different reaction conditions. Based on this, we have to decide which statements are correct and which is incorrect. So statement 1, the normality of a KMnO4 solution is 0.5 normal. What is normality? Normality is equals to molarity into N factor. So the N factor varies according to the condition, whether it is an acidic medium, whether it is a basic medium, and whether it is a neutral medium. So it will vary according to the medium condition. So the statement 1 is correct. And if the statement 2 is equivalent weight of any substance may be different reaction condition, so equivalent weight is equals to molecular weight divided by the N factor. So the N factor varies according to the medium. So the statement 2 is also correct. So our correct option is statement option second is correct. Both statement 1 and statement 2 are true. Hello students, so the question is for the reaction the I minus plus ClO3 minus plus H2SO4, it is giving a Cl minus plus HSO4 minus plus I2. The correct statement in the above equation is R. So here the reaction, the complete reaction is given. We have to take it out the half of the reaction. So the first half reaction will be I minus 2 I2, and the second half will be ClO3 minus 2 Cl. So the first half reaction is I minus is converting into I2. I minus is converting into I2, and if we balance this, it is a 2I minus. So on the reactant side, it is a minus of 2 charge. So here it will be on the product side, it will be plus of 2 electrons. Similarly, this will become a first equation, and again for the second half reaction, it will be ClO3 minus is converting into Cl minus. For this, we have to balance it by the adding of water. So here it is a 3 oxygen, so it will be a 3H2O. It will be a 3H2O, and from on the product side, it is a 6H, so it will be a 6H plus. And for the charge balance, what we will see here, it is a -1, and here it is a plus of 6 charge. So we will add a plus 6 electrons this side. We will add the plus 6 electrons this side. So it is becoming our second equation. And for the first equation, we have to multiply it by the 3 in order to cancel out. When we add both of this reaction, it will become a 6I minus, and similarly 6I2 plus 6 of electron. So this 6 electrons will cancel out. This 6 electrons will be cancelled out, and this reaction is going to be added. So the options are given. Stoichiometric coefficient of HSO4 minus is 6, and iodide is oxidized. So stoichiometric coefficient of HSO4 minus is given as a 6. So let's see, while on adding this both of the reactions, we will get, that is a 6I minus plus 6H plus ClO3 minus. It will give 6I2 plus Cl minus plus 3H2O. So this is going to our final reaction, and that is a HSO4 is also given. So we already have a 6H plus. So we will add the plus of 6 HSO4 minus on both the side. On both the side, we will add a 6 HSO4 minus plus of 6 HSO4 minus. And here it is also 6 HSO4 minus. So if we will see, it will become a 6 of H2SO4, and here it is going to be 6 HSO4 minus. So the first option is stoichiometric coefficient of HSO4 minus is 6. Yes, it is a HSO4 minus is 6. So option A is correct. Then we will, statement A is correct. And in the B statement, it is given as the iodide is oxidized. So iodide is I minus is oxidized to the I2. That is a zero oxidation state. So our statement A is also correct. Statement B is also correct. Similarly, sulfur is reduced. So here if we see in this, if we calculate as the H2SO4, for H2SO4 it is converting in HSO4 minus. So here it is not reduced, it gets oxidized. So this one is wrong. And water is one of the product. Yes, water is one of the product in our final reaction. So D is also correct. So A, B and D is correct. So it will be option C. So option third is correct. A, B, D statements, fourth is correct. A, B, D. So our correct option is fourth, that is the statement A, B and D are correct. Hello students, so the question is K2Cr2O7 plus 6 of HCl, it is giving a 2KCl plus Y of CrCl3 plus ZCl2 plus WH2O. If the above reaction is balanced with the integer coefficient, then the value of X is. So if we balance this reaction, that is K2Cr2O7 plus XH3, so we will start with the first, with this compound K2Cr2O7. So here it is a 2K, here it is 2K, so it is 2K. If we see the chromium, so here it is the chromium R2, so we are doing the hit and trial method, so it is going to be a 2. And if we see the oxygen, here it is a 7. Oxygen here it is 7. So if we see here is the oxygen is given this, so W will become a 7. Okay. So if we see from here like a hydrogen, so hydrogen is getting 7 into 2, so it will become a 14. So if I do here it is a 14. If I do here it is a 14. So let's see it again, that is a 2K is already balanced. Chromium is balancing with the 2 already. Oxygen here it is 7 and oxygen here it is also 7. Okay. If we talk about the H, on the point of the H, so here at H is 14 and here also H is 14. But if we talk about the chlorine point of view, so chlorine is also becoming a 14. And here it is a chlorine is already 2 here, 2 and 3 to 6. And for the Z, so 6 and here 2 already, like it is a 8 and 14 we have to do it. So we require a 6 also. So Z will become 3. Z will become 3. So finally it is balanced. It is a 14 of HCl plus 2 KCl plus 2 CrCl3 plus 3 Cl2 plus WH2O. So it is asking the value of the X is, so value of X will comes out to be the 14. So our correct answer is 14. Hello students, so the question is, what volume in liter of 0.1 molar NaOH is required to convert 12 gram of NaH2PO4 to Na3PO4? So we will apply here the equivalent concept. So what volume in liter we have to calculate for the NaOH? So the milli equivalent of NaOH will be equal to milli equivalent of NaH2PO4. So for milli equivalent of NaH2PO4, first of all we will calculate the moles of NaH2PO4, moles of NaH2PO4. So moles of NaH2PO4, if we calculate, the mass is given as 12 and the molecular mass of NaH2PO4 is 120. So it will be comes out to be the 0.1. It will comes out to be the 0.1, and then we have to calculate the milli equivalent of NaH2PO4, milli equivalent of NaH2PO4. So it will be the N factor for NaH2PO4, N factor for NaH2PO4 is 2. So it will be the moles 0.1 into its N factor 2 into its volume 1000. So it will comes out to be the 0.1, so it will comes out to be the 200. And for the milli equivalent of NaOH, it will be molarity is given as 0.1 into volume V equals to 200. So the volume will comes out to be 2000 ml or 2 liter. So volume will comes out to be the 2000 ml or 2 liter. So it is given the option as a 2. So correct option is option number 2. Hello students, so the question is, the equivalent weight of a metal is double that of oxygen. How many times is the weight of its oxide greater than the weight of the metal? So here we have to calculate the ratio, how much time is the weight of its oxide is greater than the weight of the metal. So the equivalent weight of a metal is given as double that of oxygen. So the equivalent weight of oxygen is 8 and it is double, so it will be the 2 into 8, it is going to be the 16. Similarly, for example, now in this question, like we have to equivalent of metal will be equal to equivalent of oxide. Equivalent of metal will be equal to equivalent of oxide. So it will be the weight of metal weight of metal divided by the equivalent weight of metal, that is a 16, and the weight of oxide divided by the equivalent weight of oxide. So the equivalent weight of oxide is just a triple of oxygen, so it is going to be the 24. So the weight of oxide divided by the weight of metal will comes out to be the 24 upon 16, that is a 3 by 2, that will be equal to 1.5. So it is the weight of the oxide is 1.5 times than that of the metal. So it is correct option is option 1, 1.5. Hello students, so the question is given below are the two statements. The statement 1, that is a HNO2 act both as an oxidizing as well as a reducing agent. Statement 2 is given the oxidation number of nitrogen may increase above +3 and may decrease below +3. So we have to judge both the statements. So for the statement 1, it is a HNO2 act as both as an oxidizing as well as reducing agent, because HNO2 it can oxidize to HNO3. HNO2 is oxidizing to HNO3. Here if we see the oxidation state, it's 1 plus of X minus of 4. So it is comes out to be the X value will comes out to be the 3. And here if I calculate, so it is a 1 plus of X minus of 6 equals to 0. So it is coming X equals to 5. So it is converting from 3 to 5. That means it gets oxidized. Similarly, the HNO2 can reduce to NO, N2O, NO, N2O. In the NO, if we see the oxidation state, it will be the +2, and for the N2O, it will be the +1. So it is getting oxidized to +5, it is getting reduced to the +1 and the +2 and the +1. So it can act as both as an oxidizing as well as reducing agent. And for the statement 2 is the oxidation number of nitrogen may increase above +3. Yes, it is increasing above +3, +5, and may also decrease below +3. It is decreasing +2 and the +1. So both the statements are correct. So our correct option is option number 2, statement 1, option 4th. Option 4th will be correct. Option 4th will be correct. Both statement 1 and 2 are true. Hello students, so the question here is, what are the values of P, Q, R and S for the following reaction? That is a PO3 plus QHI, it is giving a RI2 plus SH2O. So from this reaction, we have to take the two half reactions. Like the first half reaction is O3 is converting into H2O. O3 is converting into H2O. So when we balance this half reaction, so here it is a 3 oxygen. So we will put 3 here. So it will become a 6H, 6 hydrogen. So we will add a 6H plus here, 6H plus here, and in order to balance the charge, we will add a 6 electrons on this side. So this is our first equation. Similarly, for the second equation, for the second half reaction, it is HI is converting into I2. HI is converting into I2. So HI is converting into I2, here it is a -1, it's converting into the 0 oxidation state. So it is creating a difference of 2 electron charge. So we will add a 2 electrons on this side. And this is our second equation. In order to add both this half reactions, we will multiply this reaction with the 3. And it is a like I2 here it is, so it will become a 2HI. So it is a 2HI. So for that we have added a 2 electrons. So when we add both these equations, so it is we will get O3 plus 6HI. O3 plus 6HI will give 3H2O plus 3I2. 3H2O plus 3I2. So P will comes out to be the 1. The Q will comes out to be 6, the R will comes out to be the 3, and S will comes out to be the 3. So the value of the P is 1, Q is 6, and R is 3 and S is 3. So our correct option is option 2, 1, 6, 3, 3. Hello students, so the question is, which of the following reaction is an example of a redox reaction? So option here it is given for the redox reaction. For the redox reaction, what is the fact we have to notice? That in the same reaction, both oxidation and reductions takes place. So that reaction is called the oxidation and the reduction reaction. In the option first, the oxidation state here it is a +6 and here it is a +6. Oxygen it is a -2 and the fluorine is in -1. So no change is taking place in the first option. Similarly for the second option it is XCF6 plus 2H2O. So here it is also a +6 oxidation state. Here it is also +6 oxidation state. Here it is +6. Here it is also +6. So in the first and the second option, no change is observed. For the second option, for the third option, if we see the XCF4 plus O2F2, it is giving a XCF6 plus oxygen. So if we see here it is a xenon is in the +4 oxidation state and here it is a +6 of oxidation state. +4 oxidation state, +6 oxidation state. So it is the reduction here it is taking place. So the reduction here it is taking place. Similarly, here oxygen it is in the 0 oxidation state. Here oxygen it is in the 0 oxidation state, and if for the O2F2, if we calculate like 2x minus of 2 equals to 0. So here it is oxidation state will comes out to be the 1. So the oxidation state of oxygen is changing from the 1 to the 0. So this is our redox reaction. So this is our redox reaction. So option third is a correct option. Hello students, so the question here is the chemical nature of hydrogen peroxide is. So options are given as oxidizing agent in acidic medium but not in basic medium, reducing agent in basic medium but not in the acidic medium. Option 3 is oxidizing and reducing agent in acidic medium but not in basic medium, oxidizing and reducing agent in both acidic medium and basic medium. So the oxidizing and reducing nature, if we see the oxidizing and reducing nature of H2O2, so H2O2 in the oxidizing as an oxidizing agent, so H2O2 plus 2 electrons, it converts into the 2OH minus, and for the reducing agent, it is H2O2 is converting into 2H plus O2 plus 2 electron. So it is acting as a both oxidizing and reducing agent, both acidic as well as basic medium. So correct option is option 4. Hello students, so the question here is, consider the following equation, 2Fe2 plus H2O2, it is giving XA plus YB in the basic medium, and similarly the equation is given the acidic medium. So we have to here find the sum of the coefficients of XY and all the coefficients, the unknown coefficients. So the first reaction is 2Fe2 plus H2O2, 2Fe2 plus H2O2, it is converting into XA plus YB. So in the basic medium, the iron 2 plus will oxidize to the iron 3 plus, iron 2 plus will oxidize to iron 3 plus, and from the H2O2 it is getting converted into the OH minus. So on balancing, it will become a 2 and here it will be the 2OH minus. Similarly for the second reaction, that is a 2MnO4 minus plus 6H plus 5H2O2, 2MnO4 minus plus 6H plus 5H2O2, it is giving a X dash of C, that is it will convert in Mn plus 2 plus H2O plus of O2. If we balance this, so it will become a 2Mn, and for the H2O point of view, it is a 6 of H plus here, 5 to 10, and so it will become a 8, and on the oxygen point of view, if we will see, so it is a 8 oxygens, 8 and this 10, and here it is a 10, 5 to 10 and 8. So if we see here on the reactant side, the oxygen is 5 to 10 here it is 10, and on this side 4 to 8, Okay, so total here it is, on the reactant side it is 18, and if we see on the product side it is a 8 and 2, that is a 10. So we need a 8 more. So if I do here, it is a 4 to 8, or it will become 16. So this will be a 5 here. So this will be a 5 here. Okay. So here oxygen is 5 to 10, and here it is 8, so it will become 18, and here it is also 8 and this 10, so it will become a 18 both side. So if we have to add the coefficients here, so x if we see, the x is 2, x here is 2, y is 2, and x dash is 2, y dash is 8, and z dash is 5. So if we add all these things, like it's 8, 13, and this 15, 16, 17, 18, 19. So the value of all the sum will be, comes out to be the 19. So the correct answer is 19. Hello students, so the question here is, the volume in ml of 0.1 normal NaOH required to neutralize 10 ml of 0.1 normal of phosphonic acid. The phosphonic acid is H3PO2. The phosphonic acid is H3PO2. So we will apply here the equivalent concept. So milliequivalent of NaOH will be equal to the milliequivalent of phosphonic acid. So milliequivalent of NaOH will be equal to milliequivalent of H3PO2. So here the volume is given as volume we have to calculate, and the normality is given. So N1 into V1 equals to N2 into V2. So the normality is 0.1. So 0.1 into volume, and the millim equivalent of H3PO2. So it will be 10 into 0.1. So volume here it will comes out to be the 10 ml. So our correct answer is 10 ml. Hello students, so the question here is, when the dichromate reacts with the base, what is the oxidation number of chromium in the product? So the dichromate is Cr2O7, dichromate is Cr2O7, Cr2O7 2 minus, Cr2O7 2 minus. When react in the basic medium, that is a OH minus, it will convert into the CrO4 2 minus plus H2O. So what is the oxidation number of chromium in the product? So we have to calculate the oxidation number of chromium in the product. So it is a CrO4 2 minus. So it will be the x minus of 8 will be equals to minus of 2. So it will comes out to be the x equals to 6. X will be equal to 6. So our correct answer is 6 here.